Today we're going to review trig functions. The very first part of this is finding reference angles. In order to find a reference angle, you first need to know at least how to draw the angle that I give you. From there, what we will do is find an angle between 0 and 90 degrees that hits the line you draw and the x-axis, and that will be your reference angle. So the very first one I have is 270 degrees. Because it's a positive angle, I can label my axes counterclockwise. And since I want to graph 270 is actually a quadrantal angle. It lands right on an axis. So this red angle I drew is 270 degrees. My reference angle is an angle that hits the line and the x-axis. It has to be 90 degrees or less, so that's going to actually be this blue angle right here. The amount of degrees in that blue angle is 360 minus 270, or 90 degrees. And that's your reference angle. Don't worry about the rest of it as long as you can, of the directions, as long as you can show me where the reference angle is and give me the measure. Another example is the negative 500, so we start by graphing it. Because it's negative, we have to plot in the clockwise direction. And also it's over 360, so I go around once. By going around once, I use up 360 degrees, so I'm going to take 500 and subtract off the 360, and I'm left with 140 degrees. So graphing 140 degrees more in the negative direction puts me in the third quadrant. I need to find my reference angle, which is going to hit the line and the x-axis, but be 90 degrees or less. So my only option is that black angle. The number of degrees in that black angle is going to be 180 in the whole bottom half here, minus the 140 I didn't use in the blue portion. So I'm left with 40 degrees as my reference angle. And that's it for that. Another piece that we talked about is I gave you a point. And if you remember, when you're in a unit circle, it was easy. Your y value was equal to sine theta and your x value was equal to cosine theta. Well, we're no longer in a unit circle, so we have to graph the point that I have and find the third side of the triangle and then find the 6 trig functions. So I'm just going to do a little sketch. The point 9, negative 3 is out in the fourth quadrant. From that point, you go directly either up or down to the x-axis, in this case up, and then diagonal to the origin. I'm going to label the sides of that triangle. The x distance on that triangle is 9, and the y distance is 3. When it's talking about finding the radius r in the problem, what they're looking for is the third side of the triangle. The way we do that is use the Pythagorean theorem. So it'll be 3 squared plus 9 squared equals r squared. So that's 9 plus 81 equals r squared. R squared is 90. Take the square root. You do get the square root of 90, but like I've said in class, if you can reduce that radical, please do. That radical will reduce to 3 radical 10. So that's what my little r value is going to be right here. At this point, I can find my 6 trig functions. So I'm going to be looking for sine theta, cos theta, tan theta, and then the reciprocals as well. The angle I look at, or the theta I look at, is going to always be with the origin, so it's the blue angle. Sine is opposite over hypotenuse, so opposite is the 3. The hypotenuse is 3 radical 10. Okay, I can't leave it like that, so I rationalize. I can just multiply by the radical 10. In the numerator, I get 3 radical 10. In the denominator, radical 10 times radical 10 will be a 10. Times 3 is 30. Then I can reduce the fraction. The fraction will reduce to radical 10 over 3. Same idea with cosine. It's adjacent over hypotenuse, so it's 9 over 3 radical 10. Rationalize, so it'll be 9 radical 10 over 30 again. And then reduce, and that's going to reduce to 3 radical 10 over 10. Sorry for the messy writing. Tangent is opposite over adjacent, so opposite over adjacent is 3/9. And when I reduce, it's 1/3. Move over a little bit. We have to find the reciprocals. The reciprocals, flip your fractions. So cosecant theta, I'm going to flip my sign fraction. I'm going to actually flip the very first one, that's the easiest, to 3 radical 10 over 3, and then reduce that to just a radical 10. Secant is the reciprocal of cosine, so I'm going to flip the very first fraction, that's the easiest. That's 3 radical 10 over 9, and reduce it to radical 10 over 3. And finally, cotangent. Flip the tangent, flip the last one, 3 over 1. One step that a lot of people forget to do in this particular problem is to be able to tell me where things are positive and negative. Now I'm in quadrant 4. In quadrant 4, cosine and its reciprocal are positive. Everything else is negative. So I'm going to stick a negative sign next to sine, cosecant, cotangent, and tangent. Cos and secant will remain positive. Now that is a big problem for tomorrow, or for when you have your quiz. I asked for a lot of different pieces there. I could ask for all of that, or I could ask for just maybe 3 of the trig functions like we had for homework. So make sure you know how to do that for your quiz. Alright, the next piece of this was with the inverse trig functions. We had arcsine, arccos, and arctan. And the way you type those in your calculator is second sine, negative radical 3 over 2, second cos, negative a half, or second tan, negative 5. Okay. I want the value in both degrees and radians. We'll start with degrees first. So put your calculator in degrees. And then you type second sine, negative radical 3 over 2. You should be getting negative 60 as an answer. If you are not getting negative 60 as an answer, you might have to close a parenthesis on that radical 3 before you divide by 2. I'm going to continue in degrees. I'm going to take second cos of negative 1/2, and that's going to, you should be getting 120. And second tan of negative 5 will be negative 78.69 degrees. For the radian value, if I want the exact radian value, we can practice converting these to radians. You take negative 60, you multiply by pi, and divide by 180. We talked about this just recently. You type negative 60 divided by 180 in your calculator and change it to a fraction. It's negative 1/3, so negative pi over 3. I can do the same thing with 120. Multiply by pi, divide by 180. And then reduce the fraction to 2 pi over 3. And finally, the last one, since it's a decimal, I'm not going to use the exact way I did for the other two. What I could do, I might as well just practice typing in the calculator. Change your calculator to radian mode, and then type second tan of negative 5, and you will get negative 1.3734. For the next set of problems, find the exact value of each expression. That means I do not want decimals. So if you get a decimal, it's a radical you have to know. So please make sure you know those chart values again, because you've seen that come up over and over again these last few days. It does not matter which mode you're in when you are typing a sine or a cos or tangent and an inverse function together. No matter what mode you're in, you get the same exact answer. So that's why I'm not specific on what mode to be in. For the very first one, you type sine and then second cos of 0, and you should be getting 1. Tan, arcsine of radical 2 over 2, you should be getting a 1. If you don't, you might have to close a parenthesis on that radical 2 before you divide by 2. Cos arctan 1, okay, you should be getting a decimal there. That decimal is 0.7071. because the problem says exact 0.7071, you need to know that that's really radical 2 over 2. So that's what I was talking about before, where you need to know those chart values. All right, this next part here, I have a lot of problems that practice with cofunctions. And the reason I do is because it helps us with our reference angles as well. So we will go through this. Please pay attention to the very last problem I do. It's written a little bit differently than the ones we've been doing, but it's still important. So cofunctions was the last lesson that we had. Okay? We had sine 35. As long as your angle was less than 90, you could go straight to the cofunction. The cofunction of sine is cosine, so it equals cosine. And then you have to find an angle that adds up to 90 with that 35 that's already there. So we can subtract 35 from 90 and we get 55. So sine 35 is equal to cos 55. If you type both of them in your calculator, please make sure you're in degree mode. You should get the same value. The directions say to 4 decimal places, so 0.5736. Same idea with tangent 45. It's already less than 90, so I can go straight to the cofunction, which is cotangent. You can take 90 minus 45 to get 45. So it equals cotangent 45. It does not matter which one you type in. You end up getting 1 as an answer. For this next one, we are over 90 degrees. So since we are over 90 degrees, we have to start with our reference angles. And you start by graphing. Okay, 665, it's over 360, so I go around once. I'll try to put it here. When I subtract off the 360, I am left with 305. So going 305 degrees more puts us in the 4th quadrant. Remember, I want reference angles. So my reference angle is this blue angle right here. That the value of that blue angle is going to equal 360 minus 305 degrees, or 55 degrees. Now remember, at this point, this is just a claim. I'm going to claim to you that cosecant 665 is equal to cosecant 55. I have to type them both in my calculator to see if it's true. When I type them in, they are off by a negative. So since they are off by a negative, I stick a negative in front of it. Now that I have that piece of it done, I can go to cofunctions. The cofunction of cosecant is secant. So it'll be negative secant. And then the angle that will add up to 90 with the 55 that's already there is 45 degrees. No matter what one I type in, I should always get the same answer. That answer is negative 1.2208. Now, when I have radian values, like I do here, the very first step I should do is to convert them to degrees. Replace the pi with 180. So cos of 180, just 180 divided by 2 is 90. So I can think of this as cos 90. All right, that is, I am allowed to use 90 degrees. I don't have to find a reference angle for it. That reference angle would end up just being 0. So I have cos 90. The cofunction of cosine is sine. And the angle I'd have to use to add up to 90 with what I already have is 0. Luckily for us, sine 0 is the same in degrees and radians, so I can leave it as sine 0. No matter which one I type in, hold on one sec, I didn't actually type this one. I end up getting 0 as an answer. So my final value is sine 0 with 0 as an answer. For secant 3 pi over 2, I'm going to go below. Secant 3 pi over 2, when I convert to degrees, is secant 270. 270 is over 90 degrees, so when I graph it, we did this one earlier, it's right, that's a quadrantal angle. My reference angle, again we did this earlier at the very top, is 90 degrees. So I claim secant 270 is equal to secant 90. I type them in my calculator and it's true. I don't have to put a negative on it. So I go to cofunctions. The cofunction of secant is cosecant. 90 plus 0 will give me 90 degrees. No matter which one I type in, I end up getting an undefined. So my final answer is cosecant 0 with a value of undefined. For the cotangent, negative 3 pi over 5. First thing I'm going to do is change the degrees. That's negative 108 degrees. It's a negative degree value, so I got to graph it. I need the reference angle, which is the angle that hits the line and the axes I draw. That's going to be 180 minus the negative 108, or 72 degrees. And so I'm going to claim cotangent negative 108 is equal to cotangent 72. I type it in my calculator and it's true, so I don't need to stick a negative on it. Go straight to cofunctions. Cofunction of cotangent is tangent. 72 plus 18 is 90. 18 degrees is a radian value. Take 18 and divide by 180. Change it to a fraction. You get 1/10, so pi over 10. No matter which of these I type in my calculator, I should always get the same value as long as I'm in the correct mode. 0.3249 for that. And finally, our last problem. It says if cotangent x plus 2 is equal to tangent 2x plus 28, what is the value of x? What you have to realize about this is they're setting cotangent equal to tangent. The only time you can set a cotangent equal to tangent is to know that they are actually cofunctions of each other, just like I was doing in the other 6 problems. If they are cofunctions of each other, that means the two angles should add up to 90 degrees. So what I'm going to do is I'm going to set x plus 2 plus 2x plus 28 equal to 90 degrees and solve for x. So 3x plus 30 equals 90. Subtract 30. Sorry about the animals, guys. 3x equals 60. Divide by 3, x equals 20. You could check your work by plugging in the 20 degrees into the first part and 20 degrees into the second part, and you should see that they actually equal each other. Now, one thing that is not on this review that I would say is still a good idea to know how to do, I'm going to see if I can find some room here. I'm going to go back up to the top just because I have room. To be able to solve something like sine theta equals 0.8660, and I'll say solve for theta. So the way you solve for theta, we don't divide by sine. You take the inverse of both sides instead because there's no such thing as dividing by sine. If your calculator's in degrees, you do inverse sine of 0.8660. You should be getting around, if I round up to the nearest degree, 60 degrees. And if you remember, usually we ask for two angles that work. So that's the first one, which is we graph it, will be in quadrant 1. In quadrant 1, sine is positive. Sine is also positive in quadrant 2. Now my reference angles are equal at 60 degrees. I don't want the reference angle, I want this black angle right here. That black angle is equal to 180 minus 60, or 120 degrees. I could check my work. I could type sine 60 in my calculator and sine 120 in my calculator. I should get 0.8660 as a, or something close to 0.8660 as my answers there. If you want one for practice, try tan theta equals 0.1976. I will let you know your answer should be 11 and 191, and there will be rounding. There will be rounding involved with that. So just round to a whole number for me there. And I'm sorry it took so long, but you got to remember that you would have been in class for 40-some minutes, and we got done in 20 minutes, so it's not too bad. If you have any questions, please come see me early in the morning so I can answer them for you.